6.2 Centripetal Force. At the end of this subtopic, you should be able to define centripetal acceleration, use centripetal acceleration, AC equals to the V squared over R. Number 3, define centripetal force, use centripetal force, FC equals to the mv squared over R. And number 5, solve problem related to the centripetal force for uniform circular motion for horizontal circular motion. First, let's define what is a centripetal acceleration, and sometimes it is also known as a radial acceleration. Okay, but in this subtopic, I will always use the term of the centripetal acceleration. The symbol for the centripetal acceleration, you can declare it as a AC. What is a centripetal acceleration? Okay, actually centripetal acceleration is an acceleration of an object moving in circular path whose direction is always toward to the center of the circular path, and magnitude is equal to the square of the speed divided by the radius. Sebenarnya centripetal acceleration ni adalah pecutan memusat. So, pecutan memusat ini merupakan satu pecutan bagi objek yang bergerak dalam gerakan membulat di mana arahnya sentiasa menuju ke tengah titik bagi bulatan, okey, bagi gerakan membulat, manakala magnitudenya iaitu nilai bagi centripetal acceleration, okey, bersamaan dengan laju kuasa 2 bahagi dengan jejari. Here is the equation where you can calculate the centripetal acceleration. AC equals to the V squared over R. Okay, so I will show to you how are we going to get another these two equation. Okay, basic formula for the centripetal acceleration. Okay, you are going to use AC equals to the V squared over R. Means that this is the general equation. Okay, or you also can apply that AC equals to the R omega square. Okay, our second equation. Or you also can apply AC equals to the V omega, which is the third equation. Okay, but how we get the equation number 2 and number 3? Okay, so I will show to you how you get that two equation. Okay, first of all, we know that our centripetal acceleration AC equals to the V squared over R. Okay, in the lesson before, we have learned our speed V equals to the R omega. Okay, now we are going to substitute the V here inside the equation of the V squared over R. Okay, now substitute V as a R omega. Okay, we need to square it. So, divide with the R. Okay, so you akan dapat expand. Therefore, AC equals to the R squared omega squared divide with the R. So, R here you can cancel it out. Okay, R with the square you can cancel kan. So, we are going to get the second equation, which is AC equals to the R omega square. For the third equation, okay, again, just now you get AC equals to the R omega square. Okay, we know that again V is equals to the R omega. Okay, means that AC just now, you ada R omega ni square kan? So, saya akan tulis balik semula. R ni R. Omega yang square ni, saya akan tulis sebagai omega kan? Omega kali omega dapatlah balik omega square. Okay, so you can see that this R omega belong to V. Therefore, you akan dapat the third equation as a AC equals to the V omega. So, to find the AC, to find the magnitude of the AC, which is centripetal acceleration, you can apply either one from these three equations. Okay, so now let's declare what is the meaning of the each symbol. Okay, starting with the first AC. AC is the centripetal acceleration. V is a linear velocity or tangential velocity. R is the radius of the circular path, and omega is an angular velocity or angular frequency. Okay, so when you do the calculation, make sure AC, you must return it in the unit of meter per second. Okay, since it is a acceleration. Okay, meanwhile for the V, linear or tangential velocity, or the others name we can call it as a speed. Okay, yang ni yang kita dah belajar sebelum ni speed ni mesti constant speed. Okay, so unitnya mestilah dalam apa ni? Meter per second. Okay, manakala R must be in the unit of meter and angular velocity must be in radian per second. Okay, that is the declaration for each symbol that we have inside the formula. Okay, so part 1 for the magnitude is settled. Okay, now let's move to the direction of the centripetal acceleration. Okay, you must know that acceleration is a vector quantity, so it must have magnitude and direction. Okay, we have settled for the magnitude. Now we move on to the direction. Alright, so the direction of the centripetal acceleration, okay, is always directed toward the center of the circle and perpendicular to the linear tangential velocity, okay, which is shown in figure 6.3. Alright, so let's say, okay, this is my circular path, or I have the object, okay, and the object here make a circular motion. Okay, this is my object. My object here will moving counterclockwise. So I will get this is my first position of the object, second position, third position, fourth position, fifth position, and sixth position. Okay, as we learned before, okay, once the object move in circular motion, it will experience linear or tangential velocity, or we know it as a speed, and the speed must always constant as the object move along the circular motion. Okay, now let's draw ataupun sketch where is the direction of the speed or the linear velocity. Okay, at this position of the object, you can have that this is our tangential velocity. Again, when you draw the tangential velocity, make sure the direction of the arrow must be tangent to the circle path. Okay, so you can see that, okay, during this position, when the object moving circular motion, you can have that this is the direction of the linear tangential velocity. Okay, always tangent to the circular path. Okay, this position you akan dapat sinilah juga B-nya. Tangent pada bulatan. This position you akan dapat inilah arah, you punya arah linear velocity ataupun tangential velocity. This position also dia akan dapat tangent to the circular path, and this is also the speed where you have tangent to the circular path. Okay, and once more again, okay, bila you ada circular motion, dia mesti ada apa Dia mesti ada radius. So inilah radius R. Kan, konsep before yang saya ajar kamu tu, kamu akan dapat V dengan R sentiasa apa? Sentiasa 90 darjah. Okay, perpendicular to each other. Alright, so now, okay, cuba kamu tengok sini. Okay, mana arah AC? Okay, just now dia dah mention pada kamu. Okay, direction of the centripetal acceleration always directed toward to the center of the circle. So dekat setiap objek yang kita ada V tadi tu kan, kamu tandakan saja arah AC. So kamu akan dapat arah AC always directed towards to the center. Ini arah AC. At this position, kamu akan dapat arah AC always toward to the center of the circle. Okay, so untuk ni juga kamu akan dapat inilah arah AC always directed to the center of the circle. Okay, at this position, kamu akan dapat inilah arah AC always directed toward to the center of the circle. At this position, you akan dapat inilah arah AC. At this position, you akan dapat inilah juga arah AC. Okay, itu my first point. Okay, the second point, direction of the centripetal acceleration. Yang the N ni perpendicular to the linear tangential velocity. Tunjukkan mana kamu akan dapat. Tadi ni V kan, ini AC. So V dengan AC kamu ni always perpendicular to each other. Okay, sentiasa berserenjang 90 darjah. Ni pun sama, 90 degree, 90 degree, 90 degree, 90 degree. Ini pun 90 degree. Okay, so harap you faham lah untuk figure 6.3 ni. Okay, next point. Okay, for the uniform circular motion, the magnitude of the centripetal acceleration always constant. Apa ke bodoh ni magnitude ni? Ni yang kita dah tengok tadi. Magnitude ni sebenarnya untuk AC kan, yang tadi kamu ada formula apa ni? AC sama dengan V kuasa 2 bagi dengan R. Ini magnitude-nya. Maksudnya kan, dekat mana-mana lah tadi kan, bila kamu kira AC-nya, ni kan AC, ni AC. Kat mana-mana location kamu dapat, bila objek ni bergerak-gerakkan membulat, kamu akan dapat AC-nya sentiasa apa? Constant, tetap. Okay, but its direction continually changes as the object move around the circular path. Okay, kamu akan dapat sebenarnya arah untuk AC tu yang akan sentiasa bertukar. Keep on bertukar lah. So mana arah AC tadi? Ni lah dia. Ni arah AC. Ini arah AC. Kan berubah-ubah ni arah AC. Maksudnya arahnya kamu akan dapat always toward to the center of the circle. Okay, kenapa dia kena berubah arah? Sebab kita nak objek tadi buat gerakan membulat. Kalau kamu tak ubah arah, bermaksud objek tadi tak bolehlah buat gerakan membulat. Okay, alright, ini baru bahagian yang pertama lah. Saya terangkan dulu centripetal acceleration.